friends, I am Ramesh, Assistant Professor, Department of BC, Kongu Engineering College. So today I am going to present the journey of light inside an optical fiber transmission link. So all of you know optical fiber is the mode to transmit information or data from one place to another place with a high speed data. So through fiber optic, that is a wide communication. So today we're going to discuss the understanding the fundamental principles that how the high enabled high speed data transmission across the global networks. So throughout the world, the information exchange from one place to another place through the optical fibers. So why optical fibers? In the optical fibers, the data loss is very low, and you can transmit signals from one country to another country, or you can globally connect. So the fundamental, so what is the fundamental concept behind how the data can be transmitted? So here in the basic, the electrical signal will be converted into light signal. So the light signal will travel in the optical fiber. The optical fiber, we have core and cladding medium. So the core is the inner, so it is the diameter is very less, it is in a micrometer. So the light signal will travel in the concept of total internal reflection. So you can the input signal light reflect incident at the core. It is greater than the critical angle, the signal will fully get reflected. So when the critical angle value is greater than means fully get reflected, otherwise the signal will get refracted. So the signal may get lost, or the signal may enter into the cladding. So once the signal will travel inside the core, will travel in the long distance with the reduced loss. So that is meant by total internal refraction. When light strikes the boundary between two transparent materials at a sufficient step angle, so it reflects entirely back into the denser medium. The denser medium is, that is a core medium, rather than refracting through. So this remarkable phenomena traps light within the fiber core, creating an invisible waveguide that can transmit signal over thousands of kilometers with minimum loss. So in that we also transmit the signal for a long distance. So in between we can boost the signal. Again the light signal will be converted into electrical signal, and signal will be boosted and again converted into light, and you can transmit. So this is for capturing light. What is meant by the acceptance angle? So acceptance code means light must enter within a specific critical angle. So to be guided, already told there. So an incidence angle is greater than the critical angle, the signal will get reflected. So critical angle means the maximum angle determined by the fiber refractive properties. So and then signal loss, the light entering outside the cone, that is meant by cladding, so refracts out, causing transmission loss. So what is my numerical aperture? What is the light gathering capability? So I told the signal will travel only in the core, the total internal refraction, that is meant by numerical aperture. So dimensions numbers that quantifies the fiber ability to collect and guide light from the source. It is calculated from the refractive indices in the core. So we know N1 means the core refractive index, and the cladding means that is N2 means cladding refractive index. What is my refractive index? So the signal, that is a difference between the air medium and the medium. That is the medium may be the glass or whatever it may be. So that is when we refractive index. How the signal will get refracted in the medium when the signal travel from the air medium to another medium. So why it matters? So high numerical aperture means large acceptance angle. More light can be effectively coupled into the fiber. So critical for source to fiber coupling frequency. The paths of light optical fiber modes. So that is the light path. All of you know the modes represent distinct propagation patterns that light can follow through the fiber. Some physical parameters represent the core size, refractive index profile, and operating wavelength that will decide the path of the light. And if we have core size means the optical fiber have different modes. so step index and then a graded index like that. And also waveguide structure. The fiber acts as an electromagnetic waveguide, so constraining light specific paths. Next, that is a very important single mode and multi-mode fibers. In that single mode fiber designated to propagate only the fundamental mode of light. So that is means the core diameter it is very less, 8 to 9 micrometer. So high bandwidth capability, long distance transmission. You can transmit signal more than 100 plus kilometer. You go for single mode fiber. In that single mode fiber, you can transmit one signal at a time. Less model dispersion, so require precision laser sources. In that multi-mode fiber, you can transmit more than one signal at a time at different angles. So I means the angle will be play a major role. So if there is any same angle means the signal may get losses. In that multi-mode fiber, there is more possibility of signal losses. Here core diameter may be 50 to 62 micrometer. Easier light coupling. You can use for multi-mode fiber for short distance transmission, less than 2 kilometer within a campus like that. So model dispersion limit performance, comfortable with the LEDs. So LED is the optical source. So linear polarized modes. So you can understand the polarization. You can see the diagram. This is the electromagnetic. So linear polarized modes provide a simplified framework for describing polarization states of light waves propagating through the optical fiber. These modes categorize the complex electromagnetic field solutions into magnetopole groups, making it easy to analyze multimode fiber behavior and predict the signal characteristics. So in that multimode fibers, we already told the signal will be entered in a different angles, so that angles can be analyzed using the linear polarized modes. So in that graded index fiber structure, I told in the step index fiber means the signal will travel only into the core. So in the core refractive index will be the constant, and the cladding refractive index also will be the constant. So the signal will move from core to cladding. It will show in this diagram. It is a step size. So that is in my step index. So in the graded index means the refractive index throughout the core will not be the constant. So at the center of the core, so we have lower refractive index. When you reach into the corner, we have high refractive index. So that is why it is a curved path. So refractive index profile gradual decreases from center to edge, unlike step indexes. So curved path will be followed. Rays continuously bend back toward the central axis. So reduce dispersion, minimize model dispersion, increase usable bandwidth. So in the future, thank you.